Hello everybody, you are welcome in this channel of Electronics Lab. Today our aim is to determine and plot the operating characteristics of a PN junction diode. So this is a circuit diagram. In this circuit diagram, this is a power supply, DC voltage power supply. This is a resistance of 1 kilo ohm to limit the current in the circuit. Then this is PN junction diode. Its number is 1N407. Then a voltmeter VD and an ammeter which is connected in series, and voltmeter VD it is connected parallel to the PN junction diode. Now this is a power supply from which we are getting the applied voltage. Okay. Now this is the ammeter. It reads current in milliampere, and this is the voltmeter. So if we see this observation table, so this is first applied voltage, then voltage VD and current ID. VD is the current voltage across the diode, and ID is the current which is flowing through the diode. Now we are making this circuit on this breadboard. So this is new for us. In this lab, we are fabricating our circuits on this breadboard. What are these? Basically, there are different lines of holes. So this is one line, this is second line. So these are called rail lines or supply lines. Similarly, two lines are there. Now these are different holes. So these are called 5-hole nodes. Each set of 5 hole is shorted on the back side. So when we want to connect different wires, terminals of the component together, we will put different points in these lines that will be shorted. Similarly, there are different sets 1, 2, 3 and so on. In the lower section 1, 2, 3, there are different sections of 5 holes nodes. This is applied voltage. At this moment our applied voltage is showing value of around 8-9 volts. So this is the current ID which is flowing through the diode, and this is the voltage across diode VD. Now we can plot these readings. We can put this reading here in this observation table, and finally we have to plot the graph between VD and ID. The plot will be like this. Initially the current is low, almost negligible, but after the threshold value or cut-in voltage, that is 0.7 volt in this case for silicon devices, the current will increasing. The current will be sufficient. Now this is the forward bias. Next come to reverse bias of the PN junction diode. Now this is a circuit for the reverse bias junction diode. Similarly, only the difference is the diode is connected in reverse polarity, such that the positive terminal supply is connected to the N point of the PN junction diode, and negative terminal is connected to the P terminal of the PN junction diode. Similarly, a resistance of 10 kilo ohm is connected to the circuit to limit the current in the circuit whenever the current shoots up. This observation table. Similarly, number of readings, applied voltage, VD voltage across diode, and ID is the current through the diode. The plot of graph will be like this. In this, as we are increasing the voltage, reverse voltage across the diode, the current is almost zero. And if there is any current, that will be in microampere, shows like this. After this point, that is breakdown voltage, its value is around 600-700 volts for this particular diode. After that, a breakdown will occur. Now, but in this lab, we are applying DC voltage only up to 30 volts. So the plot will start from this and will end at this point. So this breakdown will not be shown in this case. Now this is the power supply. We are increasing the voltage. So this is ammeter. Now this is current in microampere, and this is a voltmeter VD. So this shows the voltage across the diode. So as I am increasing the voltage, now at this case, now the applied voltage is 9.3 volts, and voltage VD, voltage across the diode is 9.3 volts, and the leakage current is 1.13 microamperes. So we will put all the readings in this observation table. Similarly, we will go on increasing this value, and finally the plot will be like this. So we start from this point and we will reach at somewhere here. So this section of breakdown will not appear in this section because the applied voltage is only limited to 30 volts, which is the limitation. So this is reverse bias. Thank you.